G'day guys, done some videos, but a couple of them I did and I probably went a little bit overboard, so I deleted them. That's why there's been nothing up. But I've been working on this detector here. It's taken me around 4 hours to repair it, and it's not what you think it is. It looks like a 5000 or a 4500, doesn't it? Well, it does. If I get its box here, that's what it is. It's a Gold Seekers GDX-8000, and yep, it has no other company names on it or anything like that. And that is it, sitting down there. And the trouble with this is that it wouldn't ground balance. I don't mean an iffy ground balance. It totally would not ground balance. It wouldn't even ground balance a grain of sand. And I can see that when it left its factory, that they've had a fiddle. There was a few things that had been soldered or soldered around the place, under the board, top of the board, and yeah, I went over it and I looked at, if you can see where the oscilloscope probe is, and on the screen there, zoom in a little bit, I'll tilt it down. That channel there, second one from me, got a test point there, and that was an offset about nearly 1 volt, but it was unstable, and if I put my hands anywhere near the detector, it would go completely crazy. So it was like a grounding point was off, or something of that nature. And yeah, I did both sides of the board. I've resoldered a lot of the components there, and then it's funny because the fault changed, and then the detector would go stable, but it wouldn't ground balance. Then it would go totally berserk, still wouldn't ground balance, but it was picking up targets no problem at all, but it wouldn't ground balance. So I'm checking everything I normally check. I even thought, maybe it's the mylar and the strip, or any of the inputs there, but the it's a TLC 2022, I think it is, or 2027, can't remember what goes there. I replaced it because it was jumping all over the place, and that didn't fix the problem at all. So I said, okay. So I said, righto, I replaced the 4053, and I'll point out what I replaced. Yeah, on that one there, where this oscilloscope probe is, the test points are offset. So for this one here, it's here, there, there, and on the end one here, it sits out here. But I've just got the oscilloscope probe stuck in there at the moment. So I've replaced this low noise Excalibur op amp. It's a dual op amp, and yeah, it didn't fix it. So I put a really good one in there too, but I don't know what the other ones are. I think these are Chinese. I'm not sure. No, where it's from on it. Right. So I don't know. uh, but I suspect. But what I did find is that um, I replaced this 4053 here, and because it was acting a bit strange around that area too. It was acting unstable, and I've gone and started put it in there, and it didn't make any difference. I said, okay, what's going on here? So I'm measuring through some of the through plates, um, which run over onto these little. I don't know if you can see that, but they run onto these little inductors here. And I've got continuity. I'm really pulling my hair out. Now, what is wrong with this thing? And in the end, I found it. I mean, obviously, because it's working. And don't ask me if this ever worked or how it got out of the factory. But on pin 3 of this 4053, the track came off and it went to a through plate through the other side of the board. But between the chip leg and the through plate, there was no track. I don't know what happened to it. I don't know if it fell off, vaporized, or was eaten by some chemical or whatever. And how could it ever have worked? So, I don't know, you won't be able to see, or maybe you can. I'll zoom in on it because this is interesting. If it's common to these boards, I should really, I don't know if I can zoom in much more than that. Probably can't. But what I can do, I'll take the, I'm going to be careful doing this because last time I did this, it all wanted to push buttons and went crazy. But I'll take the camera off. Very good camera phone. There's the waveform, by the way. That's on that point where I've got the oscilloscope probe jammed into that test point on the board. And that's basically what they look like. And if I get a target and start moving it, it'll move up and down a little bit. But anyway, I'll get in on this board here. You'll see down here, I don't know there, can you see that piece of wire? I'll try and find my pokey implement here. And I've got to watch through the camera when I'm doing this. But it's a piece of wire there. Fine wire. And that's where the through plate is. But between here and there, there's no track. So without that track there, the whole thing was floating on an input. And it was causing everything to go haywire. So as you can see, I've soldered, whatever, all the components there. I've got to go give it a good clean up now and give it a coat of white paint, make it all look nice again. But over here, this is where it'd been factory fiddled around there. You can see those solder points around there. So there must have been some type of problem on this from the get-go, and maybe they thought the problem was there, but the problem was there. So yeah, there you go. That little trace of wire. This could show up on other units. That I don't know. But yeah, have a look at this. I'll get rid of this oscilloscope probe. Come here. It gets in the way. But have a look at that 200 volt capacitor on the board. The top of it looks like it's been hit with a hammer. It's got a big dent in it. I don't know how that happened. But yeah, most of the other, like here, this one gets me too. This here, that looks like it has been electrically arced onto. Two wires have touched it and it's arced onto the can. But that's not the only thing. Yeah, even having a look at those big diodes there, you know, what are they? Are they a copy of the ultra fasts that go in there? Because the I think they're on semi devices that are normally in there. They are not sharp edged like that. They are beveled and very rounded. So who knows what's in these things? It could even be, components rated for 50 hertz. I don't know. Shouldn't be. It probably wouldn't work. But yeah, it's a lot of different stuff. Even the damping resistor there. The paint's coming off it, of course. It gets hot. That is not very well. I can see something about it already. Should I mention it or should I not? Is that a spiral wound resistor? That component has to be non-inductive, right? Because it's part of the flyback. It's going to turn off and on very quickly. And if it's inductive, what's it going to do when it's turned off? Oh, I don't know. But yeah, it could cause issues generating its own back EMF. But yeah, this is what's inside this thing. It looks exactly like a GPX 4500. But it's not, because it's a GDX 8000. Mind blowing, isn't it? So that's the story with that. If you look under the board, I'm not going to lift it up. It'll probably zap me or something, that big capacitor there. But um, yeah, it's a little bit rough. A little bit rough. But anyway, this is just a repair. It's taken me ages to do it. But yeah, maybe if you guys want to repair these things, if you got your own, I can give you a rundown on all the components one day. Like where that thing is there at the front, I can give you a pointer. It's like, whoops, hang on, I'm a bit zoomed in too far. But if you look at that there, that there, that there, and that there, they're all 4053 devices, HC 4053s. And all those things there in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they are all, you can, I always get my TLEs and TLCs muddled up, but there's two versions of this. You can get JFET input devices, and there's also bipolar input devices. Both will work as long as they're all the same, and you may have to do a little bit of mucking around, but TLE 2027s, I think they are, and you can put TLC 2062s in there. Whatever has the best spec, because there's new ones out, and there's also, you can actually rip all these out and replace them with faster, lower noise devices if you want. I think it might be a Burr Brown device, but you can look up the cross references and just have a look at the frequency and noise figures of those devices. And on a cold, wet weekend, if you really want to, you can rip them all out and replace them. I've never done it. I don't think it would make much difference, because on these devices, those two things there that look the same, our little 8-legged things here, these are the most important devices in the detector. They are critical. And all that support componentry around there as well is critical. So yeah, you got some N-channel miniature pass transistors there. What are they? Like 2N7000 family, some BAV99 diodes, BF908 dual gate MOSFETs, a couple of inductors, which are very low inductance. I think they're only about 0.33 microhenries. Yeah, the rest of it's all pretty pedestrian. Those 4 devices sitting at the bottom of the frame there, that's your plus and minus power supplies, a couple of inductors and a couple of filter capacitors that feed those devices there. Those two, that's your transmit output stages for your plus 5 and plus 15. One of these diodes is connected to that, that's connected to that, so they don't actually see each other hardwired to the coil. They're each through a diode they combine, and series pass into the coil, back EMF comes through and goes through, gets through this one here, and goes into this cap. It's regulated by this MOSFET here, and the control circuitry for that is around the corner here. It's what is it? TLC 2022s, a 394 and another 2022 for memory. I'd have to look at my books. I mean, I can't remember all the chips. They're just some series MOSFETs there. Crystal oscillator, that thing there, that does a lot of the audio. That's a processor, does a lot of the switching. A lot of those switches just go and toggle that gadget, toggles that as well, changes audio parameters. There's your switch mode power supply. As you see, all the numbers are rubbed off everything again. But yeah, that's this magic detector. The quality control on this, obviously it's not a Minelab because it doesn't say it's a Minelab. It looks like one, but it's not. But the QC on this is, I don't want to be impolite, but can be improved. Anyway, that's this GDX thing. Now I've got another one I've got to fix. I fixed a few of these rotten things today, and yeah, it's some big discoveries I've made, even on some of the original detectors. I've got one over there. Someone else has fiddled a genuine 4500, and I don't know how I'm going to go on that one. Hopefully they haven't done the man-made fault, because the man-made fault's the hardest one to find. It's horrible. But anyway, guys, that's that. Um, yeah. So I don't have any problem. If you want to know what parts are what, top, bottom of the board, I can tell you what they all are. The only thing I haven't got is the code that are in that thing there. I don't have the code for that, so can't do anything about that if it goes bang. The rest of it's fairly pedestrian. Yeah, and that little chip next to it too, I can't do it. One at the bottom of the frame there. If that loses its guts, that talks to the process. It's a code loop thing. It goes hello, hello, hello back, and I know if these Renesas chips, that if you try and fiddle that and try and do anything to it, I think it does a data dump, and you'll lose all your functionality. So don't try and read the code out of that gadget. I think they might have a bit of a tripwire there. So, but no, on this one, this isn't like we think it is. I don't know. I wonder if they've actually blown the do not read fuses in that device. Might have not done that. I don't know. Might have to check that, but it doesn't really interest me because I don't have any interest in the code on these. It works as is. So there you go. Oh dear me, that's fixed. And that's the my book. I've actually drawn out GPX test waveforms there on those test points. So if you got a good GPX, you can do the same yourself, and you can just you need some bar magnets and hot rock, and you can see what does what under what conditions, and just write it down. So yeah, all good fun. Catches.